Anthropic just released Fable 5, and this is part of the new Mythos class of models, and according to the SPE benchmarks, Fable 5 is way ahead of Opus 4.8, scoring 80%, compared to Opus 4.8's 70% on agentic coding tasks. How's it? I'm Leon, and in this video we're going to see how good Fable 5 really is by putting it through an actual agentic coding workflow. Let's dive in. For this test, I do want to give Fable 5 something really challenging. All modern models, including free models, are able to build dashboards and SaaS applications, so that's no longer good enough. So what I'm going to do instead is give Fable this prompt, asking it to build a game that uses reflections and, ray tracing, so there's a lot of science and physics involved here. Now, I'm not going to go through this entire prompt. If you want, you can download it for free. I'll just link to it in the description of this video. But at a very high level, we're asking this agent to build its own game engine that's got a rendering system, a shader system, camera system, and, material system. There's actually a lot going on here, and this game should be able to run in the browser as well. Again, this is a very long and detailed prompt, but of course you can download it and try it yourself. Now, in order to access Fable 5, you do need to update to the latest version of Claude Code. Then you can go to Model, and in the model selector, you should see Fable. This is not the default model. By default, I think Opus 4.8 is selected, so just make sure that you have selected Fable. Then what we can also do is set the reasoning effort. So you can run the /effort command, and Anthropic recommends using high for pretty much all tasks. So this is kind of the balanced reasoning effort, but for more complicated tasks, which I would think we're giving it, we can set the effort to extra high. I'm also going to use this effort level for the actual implementation. Now, they also say that if you go to max level, you could actually get diminishing returns. And my guess is that the model is going to hallucinate and kind of gaslight itself into doing the wrong things. So I'm just going to stick to extra high. But please let me know in the comments what effort level you're going to use and why. Right, then let's go to planning mode, and I'm going to drop in this prompt, and we can say, please create a detailed implementation plan for this project. Feel free to grill me on the design and requirements. Let's send this. Right, so while Claude is working away at that, I do want to just discuss pricing for a second. Fable 5 is $10 for 1 million input tokens, and about $50 for 1 million output tokens. That is double the cost of Opus 4.8. This is not a cheap model. But hopefully, if the benchmarks are accurate, this could be worth it for way more complex tasks, especially when it comes to reasoning and research. And because we asked the agent to grill us, it is going to ask a few clarifying questions. So I'm just going to answer all of these questions or ask the agent to decide if I don't know. And then we'll skip ahead. Alright, so Claude just created the plan, and the first thing you will notice is that Fable 5 is really slow. It took 15 minutes just to generate this plan. And at a high level, this actually doesn't seem very, detailed or very different to what you would get usually. But I guess it's all going to come down to the actual implementation and the quality of the build. Now, for this, I am going to use my RAMP framework. So this is my development framework for building pretty much anything with coding agents. So what we'll do is actually go out of planning mode. So we can just go into edit mode or YOLO, whatever you prefer to use. Then let's give the agent this prompt. So then I'm just going to copy this prompt. This is just instructing the agent to sort of take the plan that it just came up with, create a detailed implementation plan, and then break that implementation plan up into separate feature files. Now, if you do want to follow along, as I mentioned, I've got a completely free course. You don't even have to pay a thing, you don't have to sign up, nothing. Just go to day 4 of the course. Then I've actually got two options. You can install the plan to feature skill or just copy the prompt, which is what I'm doing over here. So I'll just copy the prompt. You do have to be in edit mode for this. So then paste in that prompt. Now, basically what this is going to do is take our plan, so the plan that Fable just came up with, and create a very detailed implementation plan from that. And we'll then break that plan up into individual features. And there's a very good reason for doing that. We're actually going to use Claude's built-in goal command to implement all of these features on Autopilot. Right then, Claude is finished and it split our entire plan up into these individual feature files. And each of these files are going to be quite detailed. and we should now be able to implement this entire solution. So what I am going to do is just initiate a new repository. I'll just call this init. Cool. Then what we're going to do is actually exit out of Claude Code. Then I'm going to start it in YOLO mode because I don't want Claude asking my permission for anything at this stage. I'm just going to make sure that I do have Fable selected, which I do, and we are on extra high. Now what we'll do is run the goal command, then let's pull in this plan folder, and then let's say, please implement all features in this folder. Do not skip a thing. After each feature is completed, kick off a background agent to review the implementation. You can just use Opus as the model and resolve any issues. By the end of the implementation, kick off a final review agent to review your solution. If you guys want, you can add Fable in here, but I think for review, Opus should be good enough. And of course, I'm going to burn through a lot of credits doing this, so I'll just save a bit of bucks by using Opus here. And that is actually it. Let's send this. This will now use the built-in goal command in Claude Code to run this entire implementation on autopilot. So I'm not going to make you sit through this. This is probably going to take a very long time. So we'll skip ahead to when this implementation is completed. And we're done. This nearly took 2 hours, so please do me a favor and hit that like button and subscribe. So let's have a look at the results. There is a bit of a surprise at the end, so I do want to see how GPT 5.5 fared with this exact same task. So we'll have a look at that at the end of the video. But now this is what Fable 5 produced. And it took quite a long time, so it took nearly 2 hours and burned about 500,000 tokens in the main context window. Now, I don't think this is reliable. I'm pretty sure the background agents or the sub-agents were not included in this total. And if you have a look at my usage, I only used about 42% on my max 20 plan. And honestly, I expected this to be a lot worse. So I am quite impressed that we seem to be getting a lot more usage out of these plans. Now, I know that Anthropic might default to Opus in certain cases, but I think that's only if you're dealing with things where the guardrails kicked in, so it's sensitive data or, when it comes to security. So I'm under the impression that we used Fable 5 for this implementation. Thank you for this implementation. Now, how do I run this? All right, so I'll just run the command that Claude just gave us. Let's open this. All right, let's pull this up. All right, so we've got Mirror Forge. Right, this is freaking cool. Right, so I can see that there are reflections. I mean, we can see this little orb down here being reflected in this panel. So reflections are definitely working. This is so cool. So how do we play this? Click a mirror panel to select it. It pulses blue. Drag on the selected mirror or press Q and E to rotate it. So click on any panel. I can see it is blue. And then I can use Q and E to actually rotate it. I just noticed now that this entire background is a mirror as well. This is stupidly impressive. I can even see the reflection of the laser itself in this mirror. Oh my word. Alright, this blew me away. And look at that, if we zoom into the mirror, we can see the reflections within the actual orb as well. So it's whatever the orb is reflecting. I don't know about you, but this is stupidly impressive. But really, this was not an easy problem to solve at all, and I'm really impressed by this. So let's see if we can move the laser this way. Oh, that's awesome, so it's bouncing off that mirror as well. We can even see the laser bouncing off this little object over here. So ray tracing is definitely working as well. I mean, this is stupid and it's running in the browser. I'll actually upload this online, and if you guys want, you can play with it as well. I'll link to it in the school community. It's totally free. Then finally, let's have a look at what GPT 5.5 did. So I ran the exact same prompt. I also used the goal command. It ran for about an hour and 20 minutes. And this is the result. Now, firstly, this is not bad either. We can move around. It's very smooth. And just having a look at this orb, the reflections are there, but they don't seem quite right. But what I do like is we do have, a lot of shadows. It definitely followed the prompt properly. The laser will stop when it hits a solid object, so ray tracing is definitely available. But yeah, this is just not at the same level. It's not bad either, but definitely not at the same level. Hey, so if you found this video useful, hit the like button and subscribe to my channel for more agentic coding tutorials. I'll see you in the next one. Now, go and build something lekker.